Hello everyone, my name is Calcinez and welcome back to Cal's Micro Company. And right now this will be another video for how to use the TinkerCAD. And right now we're going to go toward the 3D printing area now. So once you complete your part right here, and I'm going to show you some areas like what's going to be the downside of it, the pros and cons, and then what to look out for in the future with your 3D printer. So um, let's go begin. So once you finish your product right here, so right now I just chose a basic shape, an animal, which is the penguin right here. Now that once you do that, you export it right here, go on STL, and that way it'll export it onto your download. It'll download onto your computer documents. So you just go on your computer, which is down here, go down here, go under downloads, and now you can actually find your part right here. So there'll be the names right here that's already been set up. Once you get to that one, then on here you'll download a software for your Makerbot printer. So congratulations on having your own printer at your own location. Depending how big it is and what small it is. Right now, I think you have the ones for mini printers, and then after that, I will do another one for the replicator too as well. But as long as they're both the same thing, it still works the same direction where we're going. Right. So on once you download it, you will see this right here. This icon says Makerbot Prints. You open that one, and it'll open up an icon. From there, it'll open up this main menu right here. So right here, you'll have all these options right here. So you have the file, edit, view, help, these side menus, and these other menus too as well. You can actually do explore makerbot.com. You can do one for Thingiverse too as well. You can explore that. You have your profile. You can actually make your account to actually keep track of it. And here's the project panel, which I'll discuss that next. And this is what it looks like from your work area. So the main thing is that connecting your printer and that connecting to your printer onto the software. So there's three ways you can have to do it. One's the Wi-Fi, another one is the internet connection, or USB transfer. Those are three options. So from here, you have these three options. So you have to add printer up here. So you go down here to printers, add printer, and you have these three options, which is true. So you have one that's the either Wi-Fi or Bluetooth IP address, which it should include it into your onto the printer itself. It will say in the back panel it's already outside with a little sticker, and it should say the IP address. Or you just connect it onto the printer online. You just like add this one, and you got to choose these methods. So we have the one for mini, and then not the Z18. We have one for um the replicator plus, which is the one you have. So either options, you just connect to that one, and it'll automatically do that. And now they have these icons. Most of them will actually say connected onto this taskbar right here, or onto this menu, and that it'll give you these options. But it'll say export it onto a USB drive. So I'll discuss that right away. So if you have, it doesn't matter which one you do. If you have replicator or mini, it's still the same thing. All you do is press that select, and that way it'll automatically select the same thing. Same thing with right here too as well. You can actually select it, and it'll automatically input the measurement of the place. So each of these will actually, or the computer will actually tells, or once you select the printer, the computer will actually find that format of what the layout looks like. And once you do that, it will actually make a dimensional accuracy on your software. So this is what it looks like on the mini. This is what it looks like as the environmental of the mini. So on your reality one, it should look similar to this right here, close as possible. But again, it should look exactly the same. Once you have that, then you have these arrows on these printers that you selected. It'll have arrows in the front, means that this is the front view, and this is what it looks like from the sides. Okay. Next one, you have these options. So you have how do you insert your model. So you just open this right here. It says new project, and then you have this right here, build plates. This is the one you'll be using right here. Right here it says new build plate. This is the one we're using right now, the new one. And over here you have two options. One, there's a little red icon right here. It says add models, or go over here to file, insert file. So they're both the same thing. So I'm gonna try add models. It'll automatically go to your download, but if you can't find it, you have to go dig through your PC files and then look for that one, the downloaded file that you have created. Then I'm gonna choose the first one that I did, but don't worry, these two should be the same thing. Open those two, and now it'll bring up this shape right here. So now on here, it will be just blank, nothing else, no color, but just a shape. The reason why, because this one on your thingy or on the TinkerCAD, it's transferred into an STL format. So STL means that it's a stereolithography file that is being used only for 3D printing only. That's it. there's different type of files out there on the computer that says either PNG, JPEG, CAD, then documents. Those ones coordinate each different ones toward the file how it's being used. And for STL, it's the same thing too as well. The STL is coordinated for the printing only. That's it. Now, the printing for the STL file for this one right here is because it'll triangulate little triangles to create a geometry shape for that. So on this surface right here, you can't really see it, but on different softwares, you just look into that one to see the geometry of it, the trigonometry. It'll create a invisible triangles. There's gonna be like either a few hundred onto this pink one, or it could be a lot, thousands and thousands of them. So it might like triangulate a half of this right here, or it could like triangulate right here like a zigzag, or triangulate any type of geometry to actually create this part right here. This may not look like a triangle, but it will create a triangle like going from here to here. So there's like numerous amount of triangles that's like shaping the geometry of it. So that's what it looks like for stereolithography. So that's what it's coordinate for 3D printing, and it triangulates the shape of your model that you created. Okay, now that once you got that one, then over here you have these options right here. So you have the settings right here. So let's focus on this one. This one is the adjust the position. So if I was gonna move this guy right here, oh, the first one you do is that you select this guy right here only. It'll turn blue, and once you got that one, it'll activate these guys right here. So this one you'll arrange the plate, build plate, and center the model. So centering the model will be centering the entire build plate. If I was gonna move over here, you got to arrange the build plate. If you have numerous items that's on here, I would not recommend this one, arrange projects, because it'll put all your parts into one build plate, so it'll like clutter itself out right away. So if you want to use that one as for like small items, if you want to print out repeated items, or print the items with different geometry, as long as it fits on the build plate, it'll print out to here onto this arrange the project. You can actually move it from the axis too as well. You can just coordinate the numbers if you can't really um, make it like really tight tolerance, if you can, to actually 3D print it. That you can actually make that possible too. Orientation. So orientation, still same thing. Select this the model that you want to print, and it'll activate these ones. So on the orientation, it'll orient any angles that you want, but these ones will actually set to 90 degrees, or you can actually have to type it in to type in the number of the what degrees you want to type it in. But it depends like how bad is your geometry of like what's gonna happen. So if you're having an object that's very hard to print out, you can actually tilt your part in the different directions, and that way it'll be close to being flat. But if you want like perfectly flat, there's a place face on the build plate. Click this one, and you can actually select this face right here. Select this face, and it'll give you these options. If you want on top, it'll flip upside down. Go to left or right, it'll coordinate this way. Front and back, it'll go front and back. So we're gonna choose bottom, and that way it'll coordinate that face onto the build plate. Done with it? Done? Good to go. And let me orient this one toward the... So, oh yeah, and also for these two right here, you notice that these one has the X, Y, and Z. The X, Y, and Z coordinates this guy right here. So if I was going to coordinate Z right here, it'll coordinate the Z axis right here. If you want to do the Y direction, it'll coordinate this direction. So if I was to do that, you guys see it tends to rotate. Same thing with the X, but it'll like rotate forward or backwards. So that's how it looks like. So that's it. Lastly is a scale. So on the scales, if you want to make it bigger or smaller on your side, or that you have to shrink it down, it's another way you can actually do it, scaling it down for smaller projects if you want to try that. Because that way, if you want to print it out into that size, but then if it can't fit, you can actually like shrink it down as much as you can to actually fit into the build plate right away. So it depends like what you want on your scale size. But kind of be careful, because there's two ways you can actually do it. One's it'll like follow each other. So if I was to type in 150, so type in 150, press enter on your keyboard, and that way it'll like make it a little more bigger. But you can actually see the numbers on the percentage. It'll like be uniform all the way, so that way it'll be like the same percentage. But what happens if I take off the uniform scale, and I want to make this guy a little more bigger, like in the Z axis, I'll make about one, or let's make it 200%. It'll stretch up by itself without affecting the others, so it'll become a little more taller. That one, yeah, like be careful how you use your uniform scale. And that, if you do get a little bit lost, just reset, or you guys are pressing that type in the 100 number if you remember it. But if you don't remember it, reset it. It'll reset everything else. Okay. Next one is the printing settings. So you have these type of settings right here. You have the ones for the base layer, extruder, infill, printer, and support bridges. If you want to add in more of the other ones, like for example, if you don't see the infill, go to custom settings, and after you choose the infills, these are the ones we'll be discussing that later on, late in the future. Right now, this is what you can actually include it. You'll have infills, and on this it'll show, or it'll say show, and you just click on those ones, it'll like show them right away. So right now, these ones used to be under show. Now it's like there's this toolbar. If it says hide, you can actually like put it back onto the settings, and that way you have to like make it like a little bit mess on this side, on this the menu side. So I just want to show it on the menu. Press done. Now you have these ones. So extruder type means that it's what type of nozzle you have on the printer. On your printers, it should be the Smart Extruder Plus. That's the one that you got to change the nozzle if anything else does happen, and we can actually replace it for you on hand once we have it on, in stock. So we do have them in, by the way. Printing mode is then balance. Basically means that it's a power station, or how it's like being let's say actually like a bounce away. I would say, oh, I don't. Um, More like it functions all the settings that you want for like the speed, the temperature, and how it's like being controlled on the first layers, but it'll be bouncing up toward like the layers down here for the bottom first one, and then it'll print up quickly right away on top. That's what it means like balance. So this one you left that on as is for the balance itself. The base layer, these ones that we have options, which is the RAF, padded base, and padded base with brims. So what it means that on RAF and padded base is used is because if your part is a little bit more larger, and if it's an exposed, like there's no glass container or anything like that, and if there's an environmental impact either from the outside or inside, there might be a chance that your part will fail, that you're printed on the bottom, it'll lift up right away. So it'll like come off the plate, and it'll like warp itself upward. So it'll like become a failure, because once that start warping up, the rest of it will affect it. And once it continue printing above here, but if it gets stuck, this guy will come off the build plate, and it'll just drag along here. So that will be a complete failure. So you have to prevent that one. So you have rafts or the brims or padded base. So those two are the ones that you can actually use. So I'll show you that one on the next simulation, how you find that. Okay. Extruder. So on your temperature for the extruders on your filaments, there should be an indication or a instructions on there that says that this is the infill filament that you have. It'll say PLA, ABS, PETG, or other filament that you have, and it'll give you the temperature of like what's the range between those two. There should be a point A range to point B range. So for example, if you have a filament, your point A range is going to be about 200 or about 195 Celsius up to 220 Celsius. That's the melting point. So you have like ones that's cooling a little bit down, but it's still hot enough. But it's gonna be hot enough, but it'll like melt, or not melt, but it'll be like really, really hot plastic metal, or hot plastic that'll be still oozing, but still like enough for it to like not cool down. So there's like different ranges on your filaments that is out there that you have to like follow right away. Because if you don't follow that one, you might clog your nozzle. You will have a failure part that will not ooze out properly, or that if you overdo it, it'll burn it, and it'll like create a precaution. So you have to like follow those instructions on the filament right away. But on your package, it will say that on the temperature right away. Infill means that in the parts, each part's like, for example, if you're doing injection molding, you notice that that part is full of plastic onto it, and it's just like a solid piece. Like for example, a square block. So if a injection molded a plastic cube that is really solid, that's a solid piece. But what if you want to like make that cube lighter? So this is where it comes in with infills with 3D printings. That if you want to like 3D print a cube, for example, I'm gonna go add in the model. glorious elephant. Now I'll show you that next one. Full plate. No, one. There we go. So for example, this right here, if you this is like a solid piece, but for the inside, if you want to add an infills of like certain percentage, so this will go by the percent. 10% is like less material, but if you go by 50%, it'll be a lot of material. So it'll be like a little bit close to being like almost filled up like a solid piece, but there'll be enough gaps of holes inside. So I'll show you that one next time. The next one right now after this. Infill patterns. There's different type of patterns out there. Traditionally, there's one for either a square or a diamond shape pattern, because that way it'll do a zigzag shape, sort of like pattern out. So that way it'll make a support columns all the way upward, and that will be a good structure right away. There's some that you can actually do like diamond, donut, hexagonal, Herbert, etc., etc. But that will be discussed later on in the future, because right now we're just talking about the patterns right now. So we'll do the diamond fill. This is one's for fast. Okay. Travel speed, it depends what's your travel speed for certain materials too as well, and also how fast you want it for your printing to be quick. But I suggest that you have to like do it like in between the moderate area. Do it too slow, it might be good for certain parts that's like too complex geometry, or if you want to do a little more faster, if it's like a like this blocks itself, not that big of a deal. But you have to be careful to like balance out the temperature, how much is being flowing out, and the speed, how fast you want to print it. But you have to be careful because it'll again cause a failure on your printed part. So you have to be careful later on in the future. Okay, supports type will be the supports that you can actually use. For example, is this elephant. So if I was gonna print this elephant and I'll change the size, and if I was gonna change the elephant, now if I want to add in the supports on the elephant itself, you can actually add in your supports right away. So guy right here. But for this one, you had to like mess around the geometry. So if I have the elephant standing upward like this, and if I add in the supports, I would say breakaway, there will be a simulation telling you that there will be supports on here. But at the same time, it'll give you a, or no, it'll give you a reading saying that this is how much is being used on your filament, and this is how much you have to use on your spool. So I'll discuss that one next. So, why it's like the pros and cons in this situation right now. Okay, and that's it. That's all I have. And that, if you want to change back your settings backwards, you can just click on this one, reset settings as default, so that way everything else will be reset right away. Okay, now we covered the basics. Now for how you actually see how it's gonna be printed out right away. So if you want to see how it's being printed out on the simulations, this one can actually simulate a tool path. The tool path is like a G code simulation, or a G code um how it's being printed along the tool path, or yeah, a G code path that it'll print out this shape right here. But it'll like say that it'll print this directions how it looks like. Certain printers and certain slicers will actually make it happen. It depends like how much it'll, you have to like change the settings every now and then. So that's one thing is being used on the printing settings, but that will be discussed later on in the future. Okay, now we go to the print overview. This one is the one you use this to actually see the simulation, how it's being played out, and how it's being filled in, or how it's gonna look like when it's being printed in the printer before you print it, and it's gonna be like a nightmare. Then you'll see like, okay, so how do I predict it to prevent that issue in the future? So we click on this one. This will give you the estimate preview about the percentage, how much it's gonna like simulate everything else. It'll like generate the geometry, how much is being used, the filament, what's being used on the filament material, then the time, and also what's the toolpath would look like being generated. So it does take a long time too as well. And also too as well, it varies differently on what type of parts that you print out. If you print out a cube, it'll load up right away quickly. But if you have a complex geometry, it might be in between. But it depends on how you change your settings that will affect your part. So it does take a while for it to as well. Like I said, it does take a while because again, it depends like how your geometry would look like, and also how you affected the printing settings. So I think I affected the, oh yeah, the infill density. That's gonna be interesting. So I'm gonna show you that one next. So it used to be 10%, and I changed it to 50%. So look at what happened on the 50% right here on the penguin from the inside. So right now it's generating the tool path as well, so that doesn't take that long. I hope everybody else loved the music in the background. So, or this is not copyrighted one, so I'm using the one for YouTube. That's good. There you go. So now this is what it looks like from the tool path and how it's being generated in a simulation. So on these ones, you have the one on the left icon, you have the scroller. You see layers of 295. So if I was gonna do like the entire full layers, it'll give me the estimate of about 590 layers of like how far it'll print out. And then I can actually bring it down to see like how well it's gonna print it out. If everything else is doing okay, because this is important because you want to know how it's gonna print out right away. And if everything else runs okay, you're good to go. And this is the one right here too as well. This is the raft. This is how it's gonna be printed out right away. So on the raft and the build plate itself, it's important to actually have this really adhere on your printing, because if you don't, it will, like I said, it'll like come off of the build plate and it'll move around with the nozzle and it will become a complete failure. Most of the times, if your brim, your raft, or your platform will fail, it's because there's no adhesion at the bottom too as well at the same time. So either your build plate failed or your nozzle contact onto the build plate was not really tight. But there's ways you can actually prevent that prevent that one happening right away. So there is like 3D communities that actually like play around with this one. They actually use like different ways to actually resolve this. You can actually use hairspray, a glue stick, and then the masking tape, which is that you use for painting. You can actually use those 2-inch ones to actually cover up your build plates rather than those skinny strips. And most of the time, they will do a combination of all of it. Like for example, if I have a build plate, they'll have a masking tape. Then you can actually add a either hairspray or stick glue, so that way it'll stick way much more better. So it'll prevent that one failure along the way. Then certain companies they'll make a more adhesive spray, which I would not recommend because again it's pricey on your budget. But again, if you want to, it will work. If it does, like if the other three have failed numerous times, you have no option to actually go for this advanced industrial adhesive. There's one for the sprayers, and there's one that they make build plates, but not for a sturdy material. They have some that are a little more flexible to actually help you out. And on there, there's little micro textures on the surface, so that way once you print it, that filament will stay contact on that surface and it'll stick onto it right away with the advanced bumps on top of it. So there'll be like a good adhesive on top. And most of the time, they will do the same thing again with the 3D community, where you can actually do numerous combinations. You can actually do one for like the build plate, the um, the adhesive layers on top of it. Then you do these blue scotch tape, hairspray, glue sticks, etc., etc. So there's numerous ways you can actually use it, but the cheapest one you can actually go for is the blue scotch tape, or yeah, um, the blue tape, then the hairspray and the glue sticks. So just in case if anything else does fail on your printing right away, so that's a heads up. Then you have the tool path movement. So if you want to move this guy right here, you guys see how it's being moved around. You guys see the tool path is like filled up. Do another one on top. 33. And then it'll like build up this tool path right away. So this is what it looks like on the tool path that is generating. And this is what it looks like that how it's gonna print it right away. It will break apart every now and then, like if you want to say like how come it's not starting from here and over there, because again it depends how you do your settings and what type of slicers software that you have on your toolpath, or you have to change it on your CAD software that you have to generate the toolpath correctly. That way you have to like prevent it from doing this right here, like it'll start randomly anywhere else around here rather than just doing like in the start to end finish. So that's the reason why you had to like do certain slicings, and there's certain softwares that will require to do that. Okay, now remember that one, the 50% infill and the raft. So if I was gonna change over here to the settings, I'm gonna change this to 10%, enter. and then I'm gonna change my raft into the brims and padded base. Then we'll see. So we could generate the preview and look at the percentage. Look how far the loading bar is, and look at it goes faster three times because we added in the infills too much, and that's a little bit too sturdy for this guy. I would not worry about this one because that way you just want like a quick printing right away. Okay, and there he is. Look for the inside, and this is what it looks like from the inside. So this is what it looks like from 10% of the diamond shape or the squares, and that way it'll create a less material. And on this side, you notice that it was at 18 grams, I believe, but now it went down to 15 grams because this is the most important one too as well on the PLA, which I'll discuss that after this one, the raft. So on the raft too as well, you notice that it went from the raft into a brim. The raft, it'll print out the entire thing, but on the brim and the padded base, it'll make it along the edges to prevent that warping too as well, at the same time as well. So that will do another one too. And I thought you can see the padded base on the penguin. You know, it's kind of like a little bit green once I move it, and that's what it looks like. Oh, sorry. And then the orange and the green, there's two different colors. This one means that this is the material that's being printed on the model, and this is the ones like the supports that will be broken off. That's the one thing it'll respond back. And from the green highlight, that's the layer height was generating. If you want to do the travel moves, that's fine too as well. You have to actually generate that one, and they'll create a tool movement. Okay, now back to this one right here. So on the weight, it says 15.88 grams. On your filaments, doesn't matter what type of spools it'll say the amount of grams or the milligrams onto it. And most of the time, it'll say either a 1 pound, 900 grams, or a maybe 90 milligrams. I don't remember what was the other one that you transfer the units. Um, the 900 grams and this 15 grams, it has to affect how much is you're being used. It does not mean that how much time you gotta use or how much spool you use. It's this one right here that's very, very important on the red dot. That's very important because on your spools and also on my side too as well, we have it'll indicate the amount of weight, how much you use on that one printing. And over time, you don't know how much you use on each projects that you use onto it, but the weight it does indicate that one. So on your I do have a PDF file for that to actually like help out individuals to see like how much you're using the material and how you like use that one the grass a bit for your next project. So like say like okay, I want to like add in materials, I want to eliminate the materials, and I want to like see how much that I'll predict it later on, how much filaments I'll be using up later on in the future. So on the format, it'll indicate like what type of filament do you have, what type of color, how much weight is gonna be. It'll always be like 900 grams, depending on which filaments you use. It'll say the weight. Then you have to transfer those ones. If you have one that's a pound or milligrams, you have to transfer or convert those units into the grams only. That's it. It'll indicate the grams. Once you got to the grams, you do the actual grams that you have minus the grams needed onto here equals the amount of grams of filament that you have right now, because that way it'll be your indicator to tell you that this is how much you use left. And in case if I was going to do another printing, so if I was going to print a cube right here and do a simulation, it's going to run everything else. Luckily this was quicker. And if I want to print another one next time, it'll say 3.82 grams. Then you use the actual grams that you used last time. Use the actual grams minus the needed grams right here into the next actual grams, and so on, so on, so on. I do have it on my PDF file. Oh no, I do have it on the Excel file. I will post it on my website, and that way you can actually download that one. But it will be But yeah, I think it should be fine. It should be. Okay. And also, you notice that the time of change it'll take about 22 minutes, so it'll be like done right away. Okay. And the most important one is the breakaway support. So if this elephant right here, and if I have the breakaway supports, So I'm gonna simulate this guy. Luckily, this one I add in the infill 10%, so he's not that doesn't take that long. But I would say that on this one, it's varies differently how you print it. If you have a cube, it'll print fine, or the penguin. The penguin itself too as well. The penguin's okay as long your tolerance is not overhang too much, because this one's okay. This is about 45-degree angle. But if it's like less than that, like 0 to 45, that's okay. But if it's 45 or beyond, that's a big no-no. You'll see why. Whoops, I think I changed that one to the elephant. Whoops, whoops. Ah, I just had it. Okay, there we go. So on the elephant, where is creating the toolpath? That's my fault. Okay, but on the elephant, you notice that this will take a lot of materials, and I would say for this one, it will be a complete failure because once you print onto these ones right here, it'll print out the foot. I would predicted it, yes, but it'll fail on the trunk and the tail because if your print is like from here, if it was like doing that tool path right here, oops, it's waiting for say right here. If it was generating that path right here, from here it'll keep printing, but if it moves to the next one, it will break right away. If it was like moving that way, it'll break either the trunk or the tail or any of these supports. It's gonna be a complete failure, and your filament or your printed part will become um a meatball right here. It's already been done, but the rest of it will become a spaghetti. So that's gonna be a big no-no, and you wasted a lot of filament. So for example, this right here, it'll take 13.89 grams. That's a lot of filament that you're using off of this elephant. So it will be ruined right away. And on top of that, you notice that your supports, it's like being used all the way through to as well, and you're wasting a lot. And this one too as well. I don't know why the simulation doesn't actually like generate a good support, but kind of be careful later on in the future because it will print this simulation and it'll like not print very well. Sorry about that. Okay. But in order to eliminate this one, I'm gonna rotate the elephant to like the axis about let's see. Okay, let me do about 45 on the negative. Negative. Oh no, it froze on me. Okay, negative 45, enter. Okay, close. There we go. I do my plus 90. Okay, good. Please don't freeze on me. There we go. So we got the elephant, and then I want to like rotate the elephant on the not the x-axis, on the y-axis. On. There we go. And it'll print it this direction right here. Most of the time, you want like your piece completely on the flat surface, so that way it'll print properly on there. Come on, rotate for me. There we go. Let me use my face. I'm gonna get to this face right here as close as possible. I think there's one right here. Here to the bottom. Because that way it'll like almost up, see? Yeah. So there's gonna be a problem. But in the future there might be some community that will help out saying that, oh, my part didn't print out didn't print out right. What can I do to actually make it possible? And there will be communities out there to actually help you out, including myself. I have known how to do this one, these animals too as well, to actually print it out very well. But it depends like how well it's being used on the simulations. So, and once I do the simulation right here, it'll estimate how much is being used on the filament and support. You notice over here it went to 13.9 grams. And if we create a tool path right here, everything else will shrink downward. And there will be no issues right away on your printing because again, on your print, it'll print this guy right here in the back, but along the way, it'll print an entire the body. So that way, this is like a strong structure. And along the way, it'll print out these columns right here, this foot and the trunk. That will be no problem too as well. The tail, my guess is like 50-50 because it's like a skinny tail. And this is what it looks like right here. So this is what it looks like generating it. And you notice that your filament is less, and that's good. And your needed is went down to like 2 grams off, so like 11 grams. So that's good news. That way you prevent your, or you can actually save your filament later on in the future, and also your time will be reduced too as well. Besides printing out the other way around, it'll like make a big issues right away. And those ones I will discuss that next time on my next video to like explain how to actually print out these parts right away, or these items, so to speak, or the models. Another way to discuss. Okay, and that's it. So now we cover everything else. We arrange your build plate, we rotate it, and we size up your scale on your build plate. You're okay on your build plate and your model. We change our settings to make them as balanced as possible depending on what you use. We look at the simulations to see how it looks like once you print it, and if you don't see any errors or nothing wrong with it, and you're good to go. Once you're done with that, you go down here to export it, and if you have three options, one, or actually two options. One is you export it on a USB drive. Make sure you attach a USB device onto your computer, and that way you can transfer that USB onto the printer that has a USB port. Or on there, if you have an internet port that's connected onto it or a Wi-Fi connected, you can actually print it onto here and it'll activate the printer right here. And that way it'll indicate saying like the printer is ready. You can do the settings right here. You can actually preheat it, and that you can actually printer prep up right away. And after that, that's it. That's all I have for today. And after that, congratulations right now on your first printing and on your way to print out more interesting models and objects later on in the future. And congratulations too as well if you now learned a lot. I will continue doing these videos next time. I will do another video that'll be the last video, next one, and that'll explain more details later on in the future. But right now, congratulations, and congratulations on your printer too as well. And then enjoy and have fun with the printer. That's it. All right, that's all I have for today. Goodbye.